This is Geometry Semester 1. It's the unit on Similarity, unit number 8. It's the 5th lesson using similar triangles to predict height practice, and it's on creatormath.com under the Geometry tab. You might have to type into Google geometrymath.weebly.com to find the site. The instructions of the practice set are: copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. Let's show that really quickly. So here's the website name, creatormath.weebly.com, right there. Homepage should pop up looking like this. If you scroll down, you should see the words composition book. If you're having any trouble with the composition book, you don't know what goes where, please go down to the website, find composition book, read all the directions, watch all the videos, follow all the due dates, and if you do what it says here, you should have a 90 to 100% on your composition book. For this, we're going to an actual problem set / lesson / video solution here that we're making for the problem set. Under the Geometry tab, you will find everything from vocabulary. Here's the Vocabulary Geometry Practice Study PDF. Download that to your device. It is searchable. Please Google how to search a PDF on the type of device you're using. If you're not getting 100% on your vocabulary practices, then you probably don't know how to use or are just not using this PDF, all right? Please figure that out and use that in those practices. Now I'm going to scroll to the semester that this video lesson is for. Here it is here. Now this is the table of contents for this semester. So table of contents, geometry, this you should have already written into pages 2 through 6 of your composition book. It's about 3.5 pages long. Should take you a little bit of time to do it, 30-40 minutes, I don't know, 30-45 minutes probably take me to write it. But once you write every line into your composition book, you're going to know what page everything goes on. If you haven't done that already, I always say stop what you're doing right now and do it right now. I'm going to scroll down to the unit that we're dealing with. Here it is here. So here's the unit, Similarity. Here's the, this is the 5th, here 1, 2, 3, there's 5 lessons. This one's lesson number 5 we're going to do today. Here are the notes, using similar triangles to predict height. Here are the pages on which the notes are to be written in your comp book. Please don't use this video to determine what pages, but go back and find the original table of contents so that, because by the time you watch this video, these page numbers will likely be different. All right, here are the notes. Fair warning, you might have to open it twice. So mine brightened up right there, and it needs to be able to be expandable. That's what I mean by loaded. If you can't read it, it's not loaded yet. All right. Expand it, write these into the proper pages of your comp book, write out these examples. What we're going to deal with is the shadow cast by the sun over one shape and intersecting with the top of a second shape, and then using a proportion to predict the height of the taller shape, right? We can measure the person here. That's supposed to be a person right there. Person in this case is 5 feet. Now we want to know how tall the building is. If we map out these different dimensions, as we'll show in the problem sets, then we can predict the height of something when we can't, go up to the building. We don't have a tape measure that long, right? And in all fairness, now a lot of the cell phone and equipment you would use to measure such a thing are using satellites to help measure these. So, but still, fun practice to understand how this is done using similar triangles or proportional triangles. So a proportion, one fraction made equal to another. Cross multiply, how we solve a proportion. Some review on feet and inches. 2 tick marks is inches, 1 tick mark is feet. Nested triangles, that's one triangle inside of another triangle. That's what makes these two proportional, because they share a common angle right there. And it's the hypotenuse leg issue, right? So let's keep going. What else have they got here? A couple examples, put those in, and let's see what the problem sets are. So, first question, what's a proportion? It's one fraction placed equal to another. So literally, draw a fraction bar and equals in a fraction bar. And this is going to be 1/2, say. The other would be something like 4/8. right? This is a proportion. It's 1/2 is equal to 4/8 because 4/8 simplifies to 1/2. And how do we solve this? We cross multiply. And if we did, 1 times 8 is 8. Say equals 2 times 4 is 8. Oh, I mean, it's so simple and so not simple at the same time. Trust me, it's a little bit brilliant right there, all right? And I hope you see a little bit of that as you get to use it and see how it interacts with these nested triangles. So, a person is 6 feet tall. Find the height of the tree using the shadow created by the sun. So here's the sun right here. Here's the shadow being cast down across the top of this. This is supposed to be a tree here, right? It's the best I can do to draw a tree. And here's a person. Okay, and it's a stick figure because that's the best person I can draw. So they're telling us that this person is 6 feet 0 inches tall. I appreciate 0 inches. That makes us 6 feet right here. I'm going to use 1 tick mark to show feet. The person is 10 feet from where the shadow ends. And the tree is 30 feet from the person, and then who is 10 feet from where the shadow ends. So this entire length right here is 40 feet. And if your eye can see this, there's a smaller triangle here, nested, which means the shared angle here, same angle of the two triangles, inside of this larger triangle here. Okay? And because they're nested, these two angles are same angle, therefore we know that these are proportional triangles, right? So we can set up a proportion to solve these. So we want to know, find the height of the tree. The tree here is this distance, so let's call it x. So let's take the height of the tree. So first, draw a proportion, one fraction made equal to another. Here we go. One fraction made equal to another. So here's a fraction bar and equals and a fraction bar, and let's see if we can fill it out. Let's start with x for the height of the tree and compare it to something else. If we compare it to the height of the person, then the 6 goes here. Now we went from larger triangle to smaller triangle. So we also know this distance here to the end of the shadow. Let's start with the larger triangle of 40 over the smaller triangle of 10. All right, so we went in order of large to small, large to small. Large to small, large to small. We stayed consistent. As long as we do that, we have a huge amount of flexibility in how we set up these proportions, which you've already seen through other units up to this point, that this can be very flexible. So let's cross multiply as the next step in solving a proportion. 10 times x is 10x. The equals remains between it. 6 times 40 is 240. I like this equation. I can divide both sides by 10. The 10 is gone. 10 over 10 is 1. 1 times x is x. And the zeros disappear, and this becomes 24. So x, the height of this tree right here, is 24 feet. So I don't have to climb up and measure that tree. I can just measure the person, the distance to the end of the shadow of the person, and the distance between the person and the tree, which I'm going to combine here to make a total distance to the end of the shadow to use in my proportion. Right? So 24 feet. Pretty cool. All right, let's see what else they ask us. All right, looks like the same problem. A person is 6 foot tall. What is the proportion? What is a proportion which can be set up? More than one answer may apply. So now we're going to get a little bit more complicated here. We're going to look at all the different types of proportions we can establish. All right. They're now using letters too. This is CD here, AB here. This is DE here, and BE here. BE is this entire length. All right, let's start with what they give us and see if we can match it up. So, AB here, CD here. AB over CD equals. Now they're going to go to BE. BE is this total length. So, they went large height to small height. Large distance, we need small distance. So we need DE. Is that what they have? Yes. Check. That's right. Let's do the next. CD over AB. Okay, this is an old trick. They flipped this fraction right here. They put the CD in the numerator position and the AB in the denominator. That's legal as long as you flip the other side. So the DE here would come up top, and the BE would go in the bottom. Is that what they did? DE over BE. Yes, that's legal too. Okay, let's go to their next one. They did AB over CD equals, and then they said DE. DE. Let's start here and see what we'd fill in. So AB is height over CD height. DE is length of the smaller. And did they say BE here? So I don't like this at all. What would I have written instead? Since they went height of the tall to height of the small, we would go distance total of the big, which in this case would be BE, and then we'd go distance of the small, which would be DE. So they flipped only one side of this, and we've already done this one, so we already have this. You can't start with AB over CD and then reverse this side only. It's all got to keep matching up. You can't now have this one flipped and this one not flipped. So this is out, this is wrong. Okay, and something tells me if I just look right here, CD over AB, I should have DE over BE, not BE over DE. This is wrong. It can't be upside down like that. You can't flip one and not flip the other in a proportion. Once you set it up like this, we can take both and flip it. But if you take one and flip it and not the other, that doesn't work. All right, so it's out. All right, so it's two answers in this case, these two. All right, given a person is 6 foot tall, more than, oh, now they're actually, okay. So now they're saying, here's the tree X, here's the height 6 foot on the person, right? They're saying which one of these proportions are right. And it looks like more than one answer may apply. So let's go through each one. Let's take X over 6. So we went X to 6 equals, then they want 40, so this whole length is 40, right? 30 plus 10 is 40. Then they went 40 over 10. So big to small, big to small. 40 over 10, check, check. Right? Now they're reversing the 6 over X, and we can just do that without even looking back at the shape. If they flip the left side, you must flip the right side. Whatever you do to one side, you must do to the other. So is this 10 over 40? Yes. Check. So something tells me now they're going to start with this X over 6, and they're going to flip this, but not this, just like the prior example. So this cannot be true. We already know that X over 6 is equal to 40 over 10. This cannot be true. No. And we already know that 6 over X, if it flips, has got to be 40 over 10. No, cannot be true. It's got to be 10 over 40, excuse me, not 40 over 10. Right? So we already found these out. We already did the work of landing them out here. These are not going to work where you just flip. You cannot flip just one side of a proportion. All right. Okay, let's see about the next page. All right, given a proportion of X over 6 equals 40 over 10, what is the first step? What is the result of cross multiplying? Here are the cross multiply. You get 10 times X is 10X and equals, and a 6 times 40 is 240. So 10X equals 240. They're just sort of taking us through the first step of solving that proportion. All right, a 6-foot mailbox. This is interesting. It's a 6-foot, this is supposed to be a mailbox here, you guys. And the sun is coming across the top of the roof, casting a shadow. It's going over the top of the roof, and it's touching the top of the mailbox. So we know right at this point it's 6. So here we have nested triangles, 6 and 10. And then this whole length here, because the house, this is supposed to be a house here. Here's the roof, like a cross section, I guess. Or we're looking at it from the side. It needs a window or two there, right? It needs a window here, maybe a door. Then it would look more like a house. Okay, so this has got to be 40 plus 10. This is 50. So if we go, we call this how high. So let me read the thing. If a 6-foot high mailbox, given a 6-foot high mailbox, find the height of the house using the shadow created by the sun. So let's make the height of the house here X. Let's say X over 6 is equal to, and we went large to small. Now we'll go large distance 50 to small distance 10. We're going to cross multiply. We're going to get 10x equals 300. Okay, we're going to divide both sides by 10, which cancels it out on the left, and we get x equals 30. All right, 30 feet right here. All right, 30 feet. So, what else we got? Number 7. All right, now it looks like they're asking us the combinations here. So we don't even need that this is 6 feet. They're asking us the combinations of, given a 6-foot high mailbox, what is a proportion which can be set up? More than one answer may apply. Let's start with the first. AB over CD is equal to. If this is AB over CD and then they go to BE, that is the one we use. BE over DE. I like that. BE over DE. That's our proportion set up. This one is correct. Check and check. Now it looks like they flip CD over AB. So now rewrite the left side, CD over AB. If you flip one side, you must flip the other. Remember, equation solving is what you do to one side, you must also do to the other. Because it has to remain balanced. If not, it just became imbalanced. So this one works too. So 2 answers work. Now, if they just repeat AB over CD and then don't flip this side, like they say instead of BE over DE, they say DE over BE, this has to be wrong. Because they flip, because we're starting with the same, we already know this one's right. We already checked it. This one has to be wrong because it's in the wrong order. Then, if they take this one and flip it and don't, right? It seems like they're flipping one side but not flipping the other. That can't be right either. So 2 answers are correct here. For the same reason that we did that prior problem. All right, so I'm going to make sure this says 5 foot. Given a 5-foot high mailbox, what is a proportion that can be set up? More than one answer may apply. So let's make the height of the house x. I kind of see where they're headed here, right? This is 50. So if we take x over 5, we went large to small. We now must go large distance 50 to small distance 10. Okay, so I like x over 5 equals 50 over 10. Check, check. Now they flip it. This is sort of an exercise in figuring out, if I flip one side, it becomes 5 over x. I must now flip the other, and it becomes 10 over 50. So this one's right too. But if they stick with this x over 5, this cannot be right 10 over 50, because we already know it's 50 over 10. Out. Same with this one, 5 over x. This cannot be 50 over 10. It has to be 10 over 50. We've already confirmed that. Right? 2 answers apply. They're both here. Given a proportion, x over 5 is 50 over 10. Let's write it out. It's a little bit easier to see it this way than in the way it's typed. 50 over 10. First step is cross multiply. 10 times x is 10x. The equal stays here. 5 times 50 is 250. Divide both sides by 10. And x, come up here, x equals, get rid of the zeros, 25. Oh, they just want, what is the result after cross multiplying? Here, 10x equals 250. Sorry, going a little bit too far there. They're just asking me for an intermediate step. All right, given a truck width is 4 feet tall. Given a truck, sorry you guys, I'll fix that by the time you get to it, okay? That's why I'm doing it ahead of you. Given a truck is 4 feet tall. So this truck is 4 feet right here. 4 feet. And that's supposed to be a truck, which I guess sort of looks like 2 tires and the front of the truck and something like this and a windshield maybe. There's the grill of the truck. That's kind of what this is, all right? It's easier for me to draw a stick figure than a truck. All right, if this is 4 feet, this looks like 1 foot to the edge of this. So again, a shadow's being cast across the top of this building and across the top of this truck. The truck is 4 feet and 1 foot from the end of the shadow. The building is 11 feet from the truck. So this total distance is 11 plus 1 is 12 feet because we need to know from here to the end of the shadow for this larger triangle. All right, so a truck is 4 feet tall. Find the height of the building using the shadow created by the sun. So we get to go straight at this one. We call this x. X over 4 is my favorite one I've set up so far. I'm just going to stick with it. We went high to low. Let's go far, 12 too close. 12 over 1. We're going in the same pattern. Large to small, large to small. Cross multiply. 1 times x is just x. 4 times 12 is 48. So this went straight to the answer. Look at that, a one-step equation right there. 4x equals 48 feet. There we go. Something tells me they might ask us a couple more options on this. 3 problems left. Okay, here's our truck, 4 feet tall. What is a proportion which can be set up more than one answer? So now we're using the AB and the CD. So AB, CD. So if we go AB over CD, and we make that equal to BE, the whole length, BE, over DE. Good. This one works, this one works. CD over AB, now they're just flipping it. I see a pattern here. CD over AB equals, I'm going to flip this side too. DE over BE. Is that what they did? DE over BE. Yes, I like this one too. Something tells me now they're going to stick with the original AB over CD but not flip it here, right? Or not use what we already determined it to be true. Out. This one here, CD over AB flips. This one must flip also. It's not these two answers. Now using the values, this being 12 here, this being x here, x over, and this being 4 here. Now using x over 4 equals 12 over 1. Good. I like that. Check, check. Flip it. 4 over x equals 1 over 12. Check. But you can't go with these because they didn't do the... We already figured these out for x over 4 and 4 over x. And these don't match what we already did. So they're out. All right, two answers here. Kind of repetitive. I think I could go back and take out 3 of these problems and be happier. Given the proportion x over 4 equals 12 over 1, what is the result after cross multiplying? I feel like we did this already. 1 times x is x equals 48. Okay, make sure you're matching up the name of this video with the problem set you're doing, otherwise it's going to cause more difficulties. This is Geometry Semester 1. It's the unit called Similarity, number 8, and it's using similar triangles to predict height practice. It's lesson number 5, and it's on creatormath.com under the Geometry tab. Hope this helps.